ओके, सो अभी तक कोई डाउट जितना भी पढ़ लिया था हमने? एनीवन?
No, sir.
नो डाउट ना?
So far, no doubt, sir.
नाउ तो इट्स अ पार्ट थर्ड वन ना, ठीक है। तो अब यहाँ पे हम क्या कॉमन सिंबल्स और स्कीमेटिक सर्किट डायग्राम वी विल स्टडी, ठीक है। वी विल स्टार्ट विद दिस वन पार्ट।
Sir, did you start recording?
हाँ हाँ, ओके। सो लेट्स first of all go for the some symbols है ना। so like if we talk about the cell, so this is the symbol for cell, okay। this is called to be positive, this is called to be negative, this is cell, okay। now am I saying correct? Yes, it's a cell na,
Yes, sir.
and this is positive, this is negative, it is
Yes, sir.
connected to like this, and so combination of cell is called battery, ठीक है। now this is a key, it's a open key,
Okay.
and this one is closed one, okay। now let's talk about the switch. so this is open switch, this is open switch,
Okay, sir.
and this one is closed switch.
So what have you written closed in the top?
Why? Closed key,
It's key. Okay.
ठीक है। is it clear?
Sir.
hmm. then let's make for the, this is a incandescent bulb, okay। then this is a resistance, and which type of, it's a fixed one resistance, ठीक है, it's a fixed resistance। then this is a variable resistance, then we have another variable resistance like this one, this is called rheostat, which is also a variable resistance, okay। clear everyone?
Yes, sir.
then
Yes, sir.
we have this as a ammeter, this as a voltmeter, then we have this as a galvanometer, okay। this is a diode, it has unidirectional flow, unidirectional flow, then a diode with the same and two arrows outward, this is an LED, that is light emitting diode, okay। now this is a normal wire, this is a two wire crossing each other, ठीक है। clear everyone?
Yes, sir.
this is a coil, heating coil or something, ठीक है। so only this much has been the important part which is you been requiring it, okay। clear everyone?
Yes, sir.
now make a schematic diagram in the form of like what, let's have this, an ammeter is connected, then we have a bulb here, then one resistance along with it, then we have battery. Always make it with the scale, okay? I'm just making it here, so it's not been done like this. Then have one switch, and here we are just closing it this, okay? So, and connecting the voltmeter with this bulb only. So V1, this is the voltmeter. Okay, so this complete circuit is called to be the schematic diagram of circuit. Okay, clear? Now whatever they say, if they say two parallel bulbs are there, one series bulb is, two series bulb are there, n number of resistors there, so whatever they are saying it, you can just draw in this diagram. Okay, got it everyone? Now where will be the current flow? Current will flow from the positive terminal to the negative terminal, that is the I. Okay,
Yes, sir.
and what is the flow of the
Electrons.
electrons? It is opposite to the
Net
direction of current, opposite to the direction of
current.
okay. Now this ammeter is doing what? Ammeter is been telling you the amount of current which is been measuring the current. This is measuring the potential difference across the bulb. This is the resistance R. It's a key, so you need to just mention it's a voltage V. This is a switch a key. Then this is a potential difference between bulb. This is a resistance, and it's a fixed one right now. And this is the ammeter for measuring the current, okay? Or we can say this is a battery,
Yes, sir.
and this the whole thing is the wire, and these are the direction of current. Got it everyone?
Yes, sir.
Now what happened? Doubt?
No, sir.
Now let's move toward the concept of resistance. Okay, so what is resistance? Any one of you?
Any kind of hindrance in the flow of current.
Yes, we can say a hindrance in the path of current. Okay, so something which stops the flow of current is called what? Resistance, or hindrance, or the obstacle. Hindrance or the obstacle.
Obstacle.
Okay, so what, how we can define this? So we can define the obstruction. See, you can write the above one also. Okay, so the obstructions offered by, oh sorry, offered to the flow of electron, offered to the flow of current by the conductor, because every conductor has its own resistance value. Okay, its own resistance value. Okay, so here we are having
Yes.
the conductor, it's called resistance, because like if you have for the aluminium, its resistance value something else, for gold it is different, for silver, that is Ag, different. Okay, getting
Yes,
my
sir.
point?
Yes, sir.
So for each and every material you have the different type of resistance. Okay,
Yes, sir.
clear now?
Yes, sir. सर रेजिस्टेंस तो क्लियर है रेजिस्टिविटी क्या है
आते हैं, उस पर भी आते हैं, वेट करो. ठीक है ना. अब क्या होता है एक्चुअली में, सी यहाँ पे हमारे पास एक कंडक्टर है, एंड दिस कंडक्टर इज हैविंग द फ्री इलेक्ट्रॉन इन इट. यस और नो? है ना
Yes, sir.
एवरीवन? इट इज बीइंग क्लियर ना? सभी को आवाज आ रही है ना क्लियरली?
Yes.
अश्रिता, नवदा, नवदा को तो आ रही है. चलो अश्रिता, निपुण, नीतीश.
Yes, sir.
हम्म सो व्हाट इज हैपनिंग हियर? हाँ, यहाँ पे हमारे पास क्या है, देखो पॉजिटिव चार्जेस भी हैं, है ना, एंड देन वी हैव सम इलेक्ट्रॉन्स ऑल्सो. Yes or no?
Yes, sir.
Now, we have studied yesterday that this is due to the flow of the electron. It's happened because of the flow of the
Electrons.
electron, है ना? So the flow of
Yes.
electron, see, if the positive charge is moving from positive to negative only, or we can say when the no potential is provided, no potential difference is provided, that means provided, that means no battery connected, no battery connected, then what will happen? These electrons will move random directions. It will move randomly. It will move
Randomly.
randomly. Okay.
Yes, sir.
ठीक
सर
है.
पॉजिटिव चार्ज भी मूव करेगा.
पॉजिटिव चार्ज मूव नहीं करता है, पॉजिटिव चार्ज डिस्प्लेस होता है अपनी जगह से. ठीक है ना, मूव
ठीक ठीक
करते हैं नेगेटिव. ठीक है, तो अब
ठीक
क्या
है.
होगा, बार बार जब ये नेगेटिव वाले जो होंगे वो रैंडम डायरेक्शन में मूव करेंगे, एक दूसरे से टकराएंगे, पॉजिटिव से टकराएंगे, तो इनका जो मीन वो निकल कर आता है ना, एवरेज जो निकल के आता है वो जीरो रहता है, यानी कोई भी उसके अंदर कंडक्टिविटी नहीं शो होती उस टाइम पे. ठीक है,
ठीक है.
तो ये
यस
रैंडमली
सर.
मूव करते हैं, ये रैंडमली मूव करते हैं पूरे वायर के अंदर. अगर आप किसी भी मेटल को उठा लो, तो मेटल कंडक्टर को उठा लो, किसी को वायर को, इट विल रिमेन देयर ओनली, एंड इट शो द रैंडम मोशन ऑफ इट. ठीक है, नाउ एज सुन एज आई कनेक्ट, as soon as I connect some potential like positive negative potential in this, so what will happen, these all, now these all charges will align. Okay, the positive will align, positive is already aligned because it's not moving only, but now these
यस
electron will get, because of the electric field, this electron will start to align themselves in a proper direction, and that is toward the, because the current is moving in this direction I, so the positive is going in this one direction. Yes, but the
यस सर.
electrons is opposite to it, so electron will start to move in the towards the positive terminal of a battery. Okay, clear?
यस सर. यस सर.
Clear this? Now, when these electrons start moving, they see. Now what happened with the electron? Na, when this electron starts to move, it moves very fast, and then after some time, it just got hit by some another electron or proton, some by electron or some by proton. So it again stop. Then again it start, and then hit it, then stop, then again start, then stop, then again start, then stop. So like this, it starts to move in a drifted form. So now the electron will start drifting, electron starts drifting now. ठीक है, getting it? What is
यस सर.
happening? See, every time what is happening, when you are being connected with the battery, now the electron will move in a particular direction. Before that, electrons do not have any direction to move, they are moving randomly. सो रैंडम मोशन की वजह से उनका जो एवरेज निकल रहा था वो जीरो ही रह रहा था, यानी कि इनिशियल वेलोसिटी उनकी जीरो ही थी. ठीक है, कोई डायरेक्शन नहीं मिल पा रहा था हमें. बट नेक्स्ट व्हेन वी कनेक्टेड इट विद द बैटरी, सो द करंट स्टार्ट्स टू फ्लो फ्रॉम हियर. Okay, now as soon as the current starts to flow, so the all electrons get aligned themselves and start moving towards the positive terminal of the battery. Yes or no? ठीक है,
यस
now
सर.
when this electron starts to move, so they do not just move in a simple way, they starts to move, then hit, then move, then hit, then move, then hit. So it starts to collide again and again, this starts to collide again and again. So this type of the motion is being done by the electron, and this is called drift. Okay, it's called drifting of the electron. Okay,
यस सर.
clear? ठीक है ना, what
हाँ
it
हाँ.
means, electrons are not just like if we are going on a race, it's not like that they are moving in a continuous manner increasing the speed, because if they it starts to move in the simple manner, they will gain the momentum and the speed will going keeps on increasing, but they do not have like this. They move, they strike, they collide, they stop, they again start the journey, then again collide, then move again, then collide, then, so it starts to move in the drift. So this velocity which is gained by the electron is called to be the drift velocity, called drift velocity. This you are going to study in class 12 again, because this is
ओके
the
सर.
actually how the current is being flowing in the conductor. This is the actual reason. because of the drift velocity of electron these current starts to flow. Getting my point?
अगर ये अभी लिख कर आए एग्जाम में तो
तो ये है ना सिलेबस में आपके?
ओके।
हाँ, अभी मैं बता दे रहा हूँ, बुक का मैं वो पार्ट भी पढ़ दे रहा हूँ ताकि आपको बुक को दोबारा ना पढ़नी पड़े, ठीक है ना, इसलिए मैं कर दे रहा हूँ वो। सुनो, अब देखो बुक क्या बता रही है, ध्यान से सुनना सभी लोग। इज इट क्लियर टिल नाउ? इट्स क्लियर, कॉन्सेप्ट इज क्लियर टू एवरीवन,
हाँ हाँ यस सर।
है ना? तो अब देखो कॉज क्या था रेजिस्टेंस का, तो इट्स सेइंग अ मेटल हैज अ लार्ज नंबर ऑफ इलेक्ट्रॉन्स एंड इक्वल नंबर ऑफ पॉजिटिव आयंस, बिकॉज इलेक्ट्रॉन और न्यूट्रॉन दोनों सॉरी प्रोटॉन और इलेक्ट्रॉन दोनों बराबर होते हैं, ठीक है? ठीक है, नाउ पॉजिटिव आयंस डू नॉट मूव while the electrons move almost freely inside the metal. Positive ions move नहीं करते हैं because it is 2000 times heavier than the electron. So who is
यस
moving? These free electron move inside the freely it's move. Okay. Now these electrons are called the free electrons. These electrons are called free electrons. ठीक है, इन इलेक्ट्रॉन्स को हम क्या बोलते हैं? फ्री इलेक्ट्रॉन्स बोलते हैं। एवरीवन गेटिंग इट?
यस सर।
ठीक है, नाउ when they move at a random, this is the random motion, okay, they collide with themselves and with the positive ions, अपने आप से भी टकराएंगे, पॉजिटिव आयन से भी टकराएंगे, and they are in the random direction. Actually the thing is here also the collision is happening, but it is not in the random direction, but this is in the A1 point is given the random direction, ठीक है? So due to which there is no flow of current, and that's why the particular conductor is not been providing any current flow at that point. Now as soon as you provide some potential, then what happened? The current starts to flow from here to here, from positive to negative. So what happened? These all the electrons get themselves aligned. Okay. So when the end of the metal wire is connected with the cell or the battery, so potential is applied across the ends of the wet wire, and electron inside, ठीक है, starts moving from and at the negative potential toward the positive, यानी कि they will start to move from the negative potential to the positive potential. Got it this everyone?
Yes, sir.
यस
This much is clear now.
यस सर।
During which their speed increases. Now when they move from negative to positive in a same direction, their speed will increase. Okay, so then speed
हाँ
increase, but during the movement they collide with the fixed positive ions, they collide with the fixed positive ions and lose some of their kinetic energy, due to which their speed decreases. तो जैसे ये इलेक्ट्रॉन के पास एनर्जी आई, इट स्टार्ट्स टू मूव, आगे पॉजिटिव वाला रुका हुआ था क्योंकि डायरेक्शन तो सेम हो गया, पहले तो रैंडमली मूव कर रहे थे, अब एवरी टाइम दे आर स्ट्राइकिंग विद द पॉजिटिव चार्ज, सो अगेन द हाउ मच एनर्जी दे आर गेटिंग, द काइनेटिक एनर्जी दे आर गेटिंग, इट अगेन बिकमिंग जीरो. Getting?
यस सर।
So like this speed is decreasing. So after collision they again accelerates toward the positive charge. अब टकराए और फिर बढ़ गए आगे. Like you play the game ना, एक कार रेसिंग का गेम होता है.
यस सर।
कार रेसिंग गेम में व्हेन यू मूव योर कार और जैसे एकदम से टकराते हो तो वो फिर से रुक जाती है और फिर से स्टार्ट हो जाती है वहीं से, है
यस
ना?
सर।
इट हैपेंस ना. सिमिलरली द इलेक्ट्रॉन्स इज आल्सो बीन मूविंग इन द डायरेक्शन नेगेटिव टू पॉजिटिव, देन आफ्टर कोलिजन इट स्टॉप्स एंड देन अगेन स्टार्ट्स टू एक्सेलरेट. Why accelerate? Because velocity is changing again and again, na? So it starts to accelerate again. Okay?
यस सर।
ठीक. So what is happening after collision? They gain the accelerator towards the positive potential due to existing potential difference. So their speed again increases. Again their speed increases, and again they got collided with the positive, and again the speed decreases. So it starts to happen again and again. Okay. So this process, as a result, what happened? It continues. This process continues. Okay. Okay.
यस सर।
This collision process continue. ठीक है, continue. Clear?
यस
Now
सर।
what happened? Now the electron do not move in bulk with continuously. ठीक है, एक सेकेंड, continuously spelling is wrong. continuously increasing speed. Okay, but there is a drift of electron towards the positive terminal. ठीक है?
Yes, sir.
Get it? So what is saying? The electron do not move in a bulk, इकट्ठा move नहीं करते हैं with continuously increasing speed, but what they do, there is a drift of electron. Drift of electron means they increase the speed, then stop, then again increase the speed, then stop, then again increase the speed, and then stop, and like this they keep moving towards the positive terminal. Okay, towards the positive terminal. Got it, everyone?
Yes, sir.
Everyone means everyone, all.
Yes, sir.
ठीक है?
Yes, sir.
कोई डाउट प्लीज आस्क मी इफ देयर इज एनी डाउट. ठीक है, अब
Sir,
नाउ
the last 31st.
क्या चीज?
31st के बाद सारी डाउट्स.
अच्छा ठीक, चलो. सो नाउ दिस इज क्लियर. नाउ दिस ड्रिफ्टिंग is depend upon the structure of the particular material, because every material has a different type of structure and different types of electron and everything na, and how much potential you are providing to that also. Yes or no? So due to which what
Yes, sir.
happen? So due to this the metal wire offer some resistance to the flow of electron. Now so from here we got the resistance. So from here we got the resistance. Is it clear, everyone?
Yes, sir.
Yes, sir.
ठीक है. Now after this, once we got the resistance, we have the topic that is Ohm's law, which is a part of the resistance only. Okay, so here we have the Ohm's law. So what this Ohm's law states, it says the current flowing in a conductor is directly proportional to the potential difference applied across its end, provided the physical condition, this is very important, and provided the physical condition and the temperature of conductor remains constant. Okay, so what it is saying, the current flowing through the conductor is directly proportional to the potential difference. Yes, so what it's saying, see, so it's saying current provided in a conductor directly proportional to the potential difference. This is only it's saying, see, the current flowing in a conductor is directly proportional to the potential difference applied across its end, provided the physical condition and temperature are constant. That is means at a constant temperature. Clear, everyone?
Yes, sir.
कोई डाउट किसी को?
No, sir.
Yes, sir.
ठीक है, क्लियर हो गया. So I is proportional to V. I is proportional to V at a constant temperature, because if you change the temperature then I won't be proportional to V. So this has been stated by whom? This has been stated by Ohms. Okay, this has been stated by Ohms. So he said now this V upon I will be equals to some constant, equals to some constant. Okay, so now from the constant, so he bring the constant, and that is said to be V upon I is equals to R. Okay, where R is resistance of that material, resistance of that material. ठीक है, getting the point or not everyone?
Yes.
So from here we got the relation as V is equals to IR, and this is said to be Ohm's law. Clear?
Yes, sir.
Yes, sir.
ठीक है. Now when a unit current means, what is the value unit current means? 1 ampere of current, okay, flows. Then when unit current and 1 ampere of current is flows, then resistance of conductor is numerically equal to the potential difference, across its end. That means now V will become equals to R. ठीक है, when I is equals to 1 ampere. Got it everyone? Is it easy right now?
Yes.
Yes, sir. Yes, sir.
ठीक है. So R is equals to V upon I. So V is voltage, I is current. So this resistance has the unit volt ampere inverse, which is also said to be ohms, So 1 volt ampere inverse is equals to 1 ohms. Okay, clear?
Yes, sir.
So this is called ohms. It's a symbol, and the symbol name is omega. The name of the single symbol is omega. Clear?
Yes, sir.
ठीक, this is the symbol name is omega.
Yeah, sir. Okay.
So we need to define the 1 ohm also. So what is 1 ohms? So 1 ohms, the resistance of a conductor is said to be 1 ohm if 1 ampere current flows through it when potential difference of 1 volt is applied across the ends of the conductor. Okay, so that is 1 ohm will be equals to 1 volt upon 1 ampere. Got it everyone?
Yes,
Yes,
sir.
sir.
ठीक है. So now we have three things: current, voltage and resistance. And for current, 1 ampere current, 1 volt of voltage and 1 ohms also. ठीक है, along with the that one part. Clear?
Yes, sir.
Now along with this we have one more thing, and that is what we have the larger value. So 1 kilo ohm, it is equals to 1000, or we can say 10 to the power 3 ohms. Then 1 mega ohm, it is 1 2 3 4 5 6, or we can say 10 to the power 6 ohm. Similarly we have 1 giga ohm. ठीक है, 1 giga, so it is a very large, we don't use generally So it's a giga ohm. So that is 10 to the power 9 ohm. Mostly you have to use this one only. Okay, clear?
Yes, sir.
Any doubt till now?
No, sir.
No. If we reverse the resistance, then we get conductance. And what is conductance now? See, resistance stops the flow or bring the obstacles in the flow of current na. Similarly, this conductance let the current to flow. Let the current to flow through the conductor. Let the current to flow through the conductor. So it is being represented by, this is represented by G. Sorry, it's the resistance na. So we can say conductance is equals to 1 upon resistance. Clear?
Yes, sir.
So we have G is equals to 1 upon R, where G stands for conductance and R stands for resistance. So both are inversely proportional to each other. So it must be having some unit also. So see, if G is equals to 1 upon R, so 1 upon R means 1 upon ohm. So it becomes G is equals to ohm inverse. Okay, or we can say ohm inverse. Get it? Now this ohm inverse, symbol inverse, or we can write it as a Simon inverse. Simon, okay, Simon, not inverse, only Simon. Simon already means ओम इनवर्स. ओम इनवर्स को ही हम साइमन बोलते हैं. क्या इतनी बात क्लियर है?
Yes, sir.
कोई दिक्कत यहां तक?
No, sir.
पक्का?
Yes, sir.
Yes, sir.
Previously we have another word. This is also called, instead of this ohm inverse we write mho. Okay, now we don't write it mho. So ohm inverse is also written as mho for the conductance. For the conductance, this G is the conductance. Okay, it let the current to flow easily through the conductor, whereas resistance do not let the current to flow through the conductor. ठीक है, clear है everyone?
Yes, sir.
Yes, sir.
Yes, sir.
The graph 1 part will start tomorrow. Now let me just give more intro part of the resistance only. Okay, now this resistance is something which we always see, the ohms. ठीक है, so at the constant temperature. So when any conductor follows Ohm's law, that is V is proportional to I at constant temperature, then we get V upon I is equals to R. Yes or no? Yes or no?
Yes.
Due to which we get linear graph for V and I. ठीक है, thus those conductors are called ohmic conductor. What it's saying? See, in the paper they may ask what is ohmic and non-ohmic conductor. So the conductor whose VI graph is a linear, VI graph means, see here, VI graph. Now if V upon I is equals to R, so can you see this one thing as a part of what? See, speed is equals to distance upon time na? Yes or no?
Yes,
So for
sir.
that we do like, so here we make I, here we make V, and this straight R, this give the slope, gives the resistance R. Okay, so this resistance tell you the VI graph. Now if this VI graph is linear, this straight line graph is also called linear graph. Straight line graph is called linear graph. Got it? Got it, everyone? So when an material follows this linear graph or diagram, it shows the linear graph, then we say that particular material is a ohmic conductor. And if it don't show, if VI graph is not linear, then we say it's a non-ohmic conductor. Non-ohmic conductor. Is it clear, everyone? Just tell me fast.
Yes, sir.
है ना?
Yes.
So for this we have the graph like any graph, not a straight line. Any graph, not a straight line like this. It's a curve. It's a curve. It's not a straight. So it's a, again it's a resistance only, but it is non-ohmic. It is non-ohmic material. Okay, it's a non-ohmic material. So example for non-ohmic can be a diode is a non-ohmic, vacuum tubes are non-ohmic. Okay, transistors are non-ohmic. Okay, this we'll study again. I just giving you the overview of it, ohmic and non-ohmic. Okay, clear?
Sir, can you explain ohmic and non-ohmic again?
हाँ हाँ बिल्कुल, definitely. See, देखो, ohmic conductors are those conductor which obeys the Ohm's law. Simple. जो ओम्स लॉ को फॉलो करेंगे दोज आर कॉल्ड ओमिक कंडक्टर, और जो ओम्स लॉ को फॉलो नहीं करेंगे दोज आर कॉल्ड नॉन ओमिक कंडक्टर. इज इट क्लियर?
हाँ, ओके.
ठीक है. अब
Yes.
बट कैसे पता चलेगा कि ओमिक कंडक्टर ओम्स लॉ फॉलो कर रहा है कि नहीं कर रहा है? तो अगर वीआई ग्राफ जो होता है, अभी हम वीआई ग्राफ को ही पढ़ने वाले हैं, उसका मैंने थोड़ा डायरेक्ट बता दिया ताकि समझने के लिए थोड़ा सा. ठीक है, तो जो इसका वीआई ग्राफ होता है, यानी वोल्टेज करंट का जो ग्राफ होता है, अगर वो स्ट्रेट लाइन आ रहा है, अगर वो स्ट्रेट लाइन आ रहा है, देन इट इज सेड टू बी दी ओमिक कंडक्टर्स. या फिर लीनियर आ रहा है तो उसको बोलते हैं ओमिक कंडक्टर है, यानी कि वो कंडक्टर जो है वो ओम्स लॉ फॉलो कर रहा है. गॉट इट? गॉट इट?
Yes.
हाँ, पर लेकिन अगर ये स्ट्रेट नहीं आता, अगर ये स्ट्रेट नहीं आता है, देन वो ओम्स लॉ को फॉलो नहीं कर रहा है, यानी कि ओमिक कंडक्टर नहीं है. तो भाई ओमिक जो ओम्स लॉ है ना, यूनिवर्सल लॉ नहीं है. ओम्स लॉ इज नॉट अ यूनिवर्सल लॉ. इट जस्ट डिपेंड अपॉन द कंडीशन ऑफ द पर्टिकुलर मटेरियल. अगर मैं टेम्परेचर चेंज कर दूंगा ना यहाँ पर, तो जो V है वो प्रोपोर्शनली रहेगा I के, एंड व्हेन V इज नॉट प्रोपोर्शनल टू I, एट दैट टाइम व्हाट विल हैपन, इट विल गिव यू दी नॉन लीनियर ग्राफ. And non-linear graph means it's a non-ohmic conductor. Getting my point? So this happens in the transistor and diode, because जैसे करंट उसमें फ्लो होता है, उसमें टेम्परेचर चेंज की वजह से चेंजेस होने शुरू हो जाते हैं. गेटिंग माई पॉइंट? थोड़ा बहुत समझ में आ रहा है? कुछ थोड़ा बहुत भी
Sir.
थोड़ा थोड़ा.
थोड़ा थोड़ा आ रहा है ना? कोई बात नहीं, आ जाएगा और अभी. ठीक है, तो अब यहां से हमारा नेक्स्ट टॉपिक जो आता है वो हो जाएगा वी आई ग्राफ. ठीक है, अभी मैं फिर से पढ़ाऊंगा ओमिक नॉन ओमिक. ठीक है, परेशान नहीं हो. इट जस्ट द ओवरव्यू आई हैव टोल्ड यू. ठीक है, सो नाउ वी विल स्टार्ट विद दी वी आई ग्राफ. ठीक है, वी आई ग्राफ को मैं कल पढ़ाऊंगा, थोड़ा सा कम कम रख के पढ़ा रहा हूं ताकि टॉपिक्स यू कैन जस्ट रिवाइज अगेन एंड अगेन. ठीक है, क्लियर है?
Yes, sir.
कोई इशू तो नहीं किसी को?
Not.
एनी डाउट टिल नाउ इन दिस टॉपिक?
Sir.
हाँ,